All right, so good evening. Thank you for attending the class. And we'll start with our new lecture on on power system control. Okay. So what is power system control? It involves the use of various technologies and methodologies in maintaining certain dynamic performance of a power system. Power system control is closely related to power system stability. So the main purpose of power system stability is always kailangan ma-maintain lang yung equilibrium. It's not perfectly equal, it's not perfectly balanced, but in a tolerable range. Okay? It's divided into two main types. Angle stability, which measures the torque balance of synchronous machines, and voltage stability, which is the ability to maintain steady state voltage. Now, this disturbance obviously will disrupt yung equilibrium na yun, such as faults and surges. Now, for practical power system network that is highly meshed with different interconnected equipment, loads, and generators, dapat in an ideal condition, meron niyang parang nominal frequency where all your loads, all your generators, all those equipments are operating at that desired frequency. So currently dito sa Philippines, obviously you're already well aware na ang ating nominal frequency is 60 Hertz. Okay? And that based dun sa Philippine grid code natin, it states there, parang yan yung sa power system operation sa transmission level, yan yung parang Philippine Electrical Code, yung mga familiar sa PEC, di ba? So meron tayong Philippine Grid Code for the transmission and then Philippine Distribution Code for the distribution level. From transmission to actually lahat ng interconnected systems, lahat yan 60 Hz hanggang baba. Okay? And we have to ensure, or the power system operator has to ensure na around that level, yung 60 Hz, nag-ooperate yung power system. Now currently, yung ating range na nakasulat doon is we should be operating within 59.7 to 60.3 Hz or that's plus or minus 5%. However, yun yung parang tolerable range. Pero syempre, yung system operator would not want to be within, parang malapit dun sa levels na yun. Like let's say 59.71. Ayaw nila ng ganun. So really, what happens is they have a more stricter range na meron silang mga different frequency control mechanisms. Particularly, ang mga nagmamanage ng frequency natin are the frequency control ancillary services. Okay? Now, yung frequency control ancillary services, currently, particularly yung tinatawag na regulation, maintains the frequency around 59.85 to 60.15. So medyo mas tighter so that you don't go beyond those levels and you don't have to be at risk of having an unstable power system na pwedeng mag-cause eventually or mag-cascade ng to outage. Ano bang frequency is not just a measure. Okay? It's not really just a measure of balance. But rather frequency, yan yung how do you say everyone's reference point, lalo na yung mga generators. So generators right now, particularly those who are connected in a highly meshed system, syempre, power system, lahat ng yan, merong when they are being developed, syempre may standards yan nung dine-develop yung mga power generation natin. And those standards involved when you build a power plant, lalo na yung controls yan, that they meet those standards. And one of those standards are that they should have, mostly ay mga bago, have governor controls. That will obviously, kapag ka nag-sync na yan sa system, alam na niya yung kagad yung system frequency. It's universal in that grid. Okay? At alam niya na yung frequency na yun, doon siya nag-ooperate. If it senses frequency, syempre meron siyang yung mga generators, meron niyang mga deadband setting where they will be moving based on that deadband setting should the frequency be beyond such beyond designated levels. So magre-react siya. Now, if we have a frequency that is grossly imbalanced, what happens is, syempre, yung generator has its own protection mechanisms and will try to isolate itself o magtitrip siya. I-trip niya yung sarili niya kaysa masira siya kasi kunwari masyadong bagsak yung frequency, hahabulin niya yung frequency na yun para mag-operate din siya so that it can compensate for that drop in frequency. Pag hindi niya kayang habulin yun, let's say fully loaded na siya as generator at masyadong mabilis yung tinatawag na droop setting, it will trip itself. Pag nag-trip pa siya, edi lalong naging imbalance pa lalo yung generation and load. So eventually that can cascade to a blackout. And we don't want that to happen. A blackout will take us hours to days just to be restored yung power system natin. Okay? So that's an important message on how frequency is really parang tinitake lang natin lightly, but it's really a very important measure. However, as I've said, power system is imperfect. Laging gumagalaw ang load. Laging lalo na pagka nung bago tong ECQ, medyo ganun pa rin naman even during this ECQ. Pagka umaga, when we wake up until the morning peak, medyo magalaw yan kasi hindi naman tayo pare-pareho ng just like what we've said in the last lecture on dynamic programming, no, or yung unit commitment. Loads are following yung human cycle or human activity cycle. So sa umaga medyo magulo kasi hindi naman tayo pare-pareho ng activity sabay-sabay. But once we are working na sa offices or talagang stable na yung ginagawa natin for the day, yun medyo predictable na siya. And that challenge of loads being not everyone operating in sync, di ba? And as well as generators operating din kasi kanya-kanyang ramp up, ramp down, start up. So it can be a challenge as well to maintain that balance. So again, as also mentioned, ito yung fourth bullet, electrical power output of generators is dependent on the rotational performance of synchronous machines. Machine must maintain its synchronous speed for normal operation. Now, what is the transient stability? It's the ability of the power system to maintain synchronism when subjected to a severe transient disturbance such as a short circuit on a transmission line. Now, a power system is transiently stable for a particular steady-state operating condition and for a particular large disturbance or sequence of disturbances if following that sequence of disturbances reaches an acceptable steady-state operating condition. So ito yan, if there is an sudden incident of a disturbance, ito yan, yung first swing of instability, it will cause the system frequency to be out of that stable operating condition. Now we have also what we call voltage stability, which is the ability of a power system to maintain steady, acceptable voltages at all buses of the system after being subjected to a disturbance from a given initial operating condition. Now, by which yung sequence of events nag-cause ng voltage instability will lead to a blackout or abnormally low voltages in a significant part of the power system. That is what we call voltage collapse. Now, kanina frequency control. Now, this is a different aspect of stability naman. or power system control yung voltage. So, although maraming parameters na ino-observe sa power system operations, the main parameters really that can tell you how stable the power system is first, frequency, stability. Next will be voltage stability. So, yun yung dalawa. So, yung voltage na yan is very important. Di ba? If we have an extremely, relate natin, if we have an extremely low voltage, okay? Remember that yung mga equipment natin are operating based on yung need nila na megawatt, okay? Yung work needed to operate as their equipment. So, yun yung megawatt, okay? Now, that work, obviously, is a product of syempre, voltage and current at the basic, no? And that product, if you have a very low voltage, kunwari, 10 megawatts, okay? Kung normal, kunwari, let's say, yung BNI mo, okay, to sustain 10 megawatt consumption, ito yan. Pero pagka, remember, di ba, pagka power is equal to voltage times current, I hope you remember that. Although yung basic, yung pinaka-detail niyan, obviously, marami pang details. But at the most basic, pagka bumaba ang voltahe, to maintain the same amount of work or megawatt, you have to increase the current. Problem with that, increasing current, is obviously that creates heat, alam naman natin, loss, and eventually, yung heat na yon, lalo na yung mga machines, can burn up our machines. And what will happen is, syempre may mga protection mechanisms din naman yung mga machines na yan. Obviously, loads will also trip. Now, if loads trip, again, pabalik tayo dun sa nag-cause ka ng imbalance again. Kasi kung ito yung generation and load na balance, biglang nag-trip yung load because of a very low voltage, you create that imbalance at pag hindi nakahabol yung generation to go down, it can result to knockout. Okay? So remember, ang point of reference natin, load. Okay? Point of reference. For frequency stability kasi, the ability of a power system to maintain steady frequency following a severe system upset resulting in a significant imbalance between generation and load. So sabi ko, reference natin is load. If this is load, is your generation. If you have more than or higher generation, tawag doon over frequency. Okay, excess generation. If you have a lower amount or deficit generation, that's under frequency. Okay, so reference point natin is the load. How do we address voltage issue, or how do we control voltages in buses? The voltage on the power system is primarily dependent on the reactive power or MVAR. Now, how do we source it? Generators are sa ngayon, it's one of the primary sources of MVAR control generators. Okay? Because of its excitation system, it can operate at its own voltage at that bus, at its own bus. So kapag kunwari, sabi nung power system operator, sir, magdagdag ka nga ng inductive MVAR to help the power system kasi yung mga nearby areas mo low voltage na. So that can help, that generator can help address that low voltage issue by injecting either inductive or capacitive MVARs. In that case, sabi ko nga inductive. Now we also have capacitors and reactors. Now capacitors are normally located in areas na mababa ang voltahe, which is obviously mababa voltahe is in areas na malapit na sa load, okay, sa mga load centers. Now for reactors, ito naman ay para dun sa mga areas na masyadong mataas yung voltage. Kanina yung capacitor, pag mababa voltahe, tatry niyang iakyat yung voltahe dun sa currently ang operation dapat ng voltage is between 0.9 to 1.1 per unit. Okay, so tatry niyang iakyat yung pagcapacitor. Pagka reactor naman, masyadong mataas yung voltahe, kaya kailangan niyang ibaba. Okay? Now, mostly those reactors are located in near pagka nag-step yung sa generation areas, pag nag-step up na ng kanilang output, dun sa mga areas usually like dito sa Philippines, dun sa 500 kV system natin, maraming reactors dun. Okay? Synchronous generators are the common generator in a power system, obviously. And the reactive power of a generator is dependent on its excitation system. The main function of a generator excitation system is to provide DC current to a field winding, and the field winding is the primary responsible in maintaining proper voltage at the generator terminal. Generator exciter can be quickly modified for voltage regulation. However, M-bar production of generator depends on its capability and availability. So may tinatawag na M-bar capability curve ang mga generators. Like for example, if it's, let's say it's a 300 megawatt generator, merong convention yan usually, which we call it the D curve, no? Parang estimate siya. Now, in levels na kunwari, pag siya ay nag-ooperate at full capacity, it can operate at an inductive M-bar of 0.8 of its full capacity. So 300 times 0.8, okay? That will be 240. So 240 M-bar inductive and then 0.6 capacitive. So that will be 180 o negative 180 M-bar yun. So yun yung operational or M-bar capability niya at 300 megawatts. Pero pagka hindi siya nagpo-full capacity, nag-iiba rin yung hindi na 0.8, 0.6. Sometimes yun nga di siya, no, can be at a range of 0.4 to 0.2. It depends on obviously different generators have different capabilities. Okay? So very limited ang M-bar capability niya depending obviously on where its megawatt is. Hindi so ang pwede lang mag-sustain ng very high M-bars. Beyond. So makikita nyo, no, parang hindi never nag-operate yung sa ganung ratio. Never nag-operate yung generator with a higher M-bar than its megawatt. Pero yung kayang mag-operate na generator M-bar na more than its megawatt are tawag doon synchronous condensers. But we have rare synchronous condensers in the power system. Most of our generators are synchronous generators. This is a simple diagram, a block diagram of how an excitation system is operating. Okay? So when the generator is synced to the power system, itong area na to, siya yung nakasync dyan. It obviously reads kung ano ba yung voltage, and obviously para hindi siya maapektuhan sa system, it has its own limiters and protective circuits. Eventually, that regulator will determine ano ba yung level ng voltage, okay, sa system, nababasa niya yun. Now, if it obviously the generator has to operate on its own voltage level. Kung nandun siya nag-ooperate dun sa voltage level na yon, that generator, syempre depending rin sa M-bar capability niya, will initiate yung exciter niya to eventually emit some M-bars. Okay? So, merong feedback mechanism yan, yung power system stabilizer, if it needs further M-bars as instructed by the power system or the power system operator. Okay, yan. Exciter provides DC power to generator field winding. The regulator processes or amplifies input control signals for exciter control or feedback amplifier. Whereas the power system stabilizer provides additional input signal to the regulator to damp power system oscillation. Limiters and protective circuits ensure that the capability limits of the exciter is met and protected. So yan yung parts ng ating excitation system. Now on the frequency control, frequency is controlled by balancing supply and demand. Now the governor system in generators senses any change in rotational speed to adjust its mechanical input power. There are different modes of operation for generators for frequency control. We have the droop mode, which decreases in speed. Nagde-decrease siya ng speed due to the increase in load. So if the frequency decreases, so bumaba yung frequency, di ba? The governor will respond, yung governor control niya will respond by increasing fuel output unit until reference speed is obtained. Yung reference speed, yung frequency. So aakyat siya. Magbibigay siya ng additional power. Siyempre, kasi mababa yung frequency. Meron kang deficit. Droop mode ensures that the increase in fuel position is enough to prevent overspeeding when the system is returning to normal. Siyempre, kanya maraming generator, pwede mag-contribute all at the same time. And at the same time, yung loads, hindi mo rin alam. Baka mamaya, bigla namang, kunwari, nagko-contribute ka, bigla nag-stop yung load or bumaba konti. So, nag-contribute ka ng sobra agad, edi nag-overshoot ka. So, to ensure that, yan, droop mode na yan, to ensure na hindi ka nag-overshoot or maybe just a little bit para hindi naman ganun because you never know really in real time exactly kung ano yung magiging levels of the load and even the other generators operation. So yan, droop mode will prevent overspeeding. So in a mesh network with several generators, they need to adjust its speed at a single reference to ensure that each generator will adjust to demand proportional to its capacity. So minsan ang ginagawa niyan is yung setting niya is meron siyang ratio na parang kapag nag-contribute ka ng generation, this amount of power lang. Kasi yung iba daw ang ina-assume magko-contribute ng some amount of power din. Isochronous mode is a fixed frequency regardless of load. The governor will maintain its frequency setting of the generator despite load variation. Now, normally it's used in isolated systems. Like for example, I'm not really sure, no, kasi hindi transparent sa akin yung ibang island operations natin like sa Palawan, Marinduque. So those islands na may sariling power grid that is isolated from the Luzon, Visayas, and Mindanao grids. I'm not really sure kung how they operate their frequency, no. But normally it's the same. Generation, power, generator power generation and control blocks. Now we have, so here is your automatic generation control ng isang generator. Not all generators have AGCs. Now AGCs are currently in the power system dito sa Luzon and Visayas and Mindanao. Generators that are controlling frequency to regulate them. So tawag dun sa mga yon, load following frequency regulation generators. Yung mga generators na yan have been equipped or are equipped with AGC or automatic generation control. Now, what does the automatic generation control do? Okay? So, alam niya, etong AGC kasi na to takes a command, okay, from the power system operator. Yung power system operator na yon, syempre in the Philippines it's NGCP. Meron siyang EMS or energy management system, and part of its EMS is its SCADA system, no. Part of its EMS is the AGC, where syempre yung power system operator nakatap din siya sa system frequency. Since it knows the frequency and it knows what level of generation should be provided to address frequency issues in real time, it will initiate commands to the generator via AGC. Okay guys, mag-stop to ng please log in kasi mag-cut na naman yung recording because of that 40-minute limit nitong call. So please log in lang uli and we'll resume.